In this part, I will give you a high-level overview of all the different container services you can use on AWS. So if you want to run a containerized application on AWS, you have multiple options to choose from depending on your application requirements. So we'll go through all of these options one by one. We will see what ECS, Elastic Container Service, is and what it's used for. Then we'll compare it and talk about EKS, which is Elastic Kubernetes Service. We will also see different ways of running containers with EC2 or AWS Fargate. And finally, we will see the ECR service, which stands for Elastic Container Registry. Now think about a microservice application scenario. If you're developing microservices, you would need containers for each, and containers scale pretty quickly. Maybe you create replicas, you have different third-party services and applications for your microservice application. This could be messaging systems, authentication services, etc. So you end up with a bunch of containers that you need to deploy on some environment. In this case, we're talking about AWS virtual servers. So let's say we have created 10 containers for each our 10 microservices, plus we have 5 other containers that our microservices use, which run different applications. And let's say we deploy all of those on our EC2 instances, which have Docker installed on them. Now, once you have deployed them, how do you manage them? So you have an infrastructure of all these virtual servers that are running all your Docker containers. How do you know how much resources you still have remaining on these machines? How do you know where to schedule the next container? How do you know by looking across your infrastructure whether some of your Docker containers are not running anymore, whether servers ran out of resources? And when you see that some containers have died, do you manually restart each container? If you have maybe 5 replicas of one application container, how do you set up load balancing for them? Also, if you have maybe 50 replicas of an application which you don't need anymore, how do you get rid of all those containers? Do you stop them and remove them one by one, or write a custom script or shell command? Or if you have 10 replicas of a container, how do you know whether you wanted 15 or 10? Whether this is the actual wished or desired state? Would you remember the initial desired state? And these are all things that you need to manage when you have tens of containers, maybe hundreds of containers that you need to manage on your infrastructure. So obviously you need some kind of automation, some kind of tool that can help you with all these issues. And all these things that I just mentioned are features of a container orchestration tool. So you probably already know one of them, which is the most popular orchestration tool, Kubernetes. But of course, there are multiple orchestration tools out there. Docker Swarm is one of them, which is for less complex, a bit smaller containerized applications. You also have Mesos, Apache Mesos. You also have HashiCorp Nomad. And you also have an AWS service called Amazon Elastic Container Service, ECS. So ECS is one of the container services that AWS offers, and it is essentially a container orchestration service. So ECS, being an orchestrator for containers, will manage the whole lifecycle of a container. When you start the container, if it needs to get rescheduled somewhere, if it needs to get restarted, load balanced, etc. So how does this service actually work? On AWS, if you wanted to create a cluster, a container cluster basically, that is managed by AWS ECS service, you would create an ECS cluster. And that ECS cluster will basically contain all the services that are necessary for managing the individual containers. So ECS cluster basically represents a control plane for all your virtual machines that are running containers. And that control plane and the services, the managing services in that control plane then can manage these individual containers and do all these things that I mentioned before, like rescheduling the containers, making sure the desired and actual state are the same, and essentially managing the whole life cycle of a container from being started and scheduled to being removed. When you create ECS cluster, as I said, you have the control plane, but the containers need to run somewhere, right? So containers need to run on actual machines, on virtual machines. So where do these virtual machines come from? These virtual machines will be the EC2 instances. Just like before, we would create an EC2 instance that will basically host the containers. So the containers will run on EC2 instances just like we did previously. However, this time the EC2 instance will not be isolated and managed by us completely, but EC2 instance will be connected to this ECS cluster that we created. So rather than just being independent, isolated, managed by us, now EC2 instance will be connected to the ECS cluster and will be managed by the control plane processes on the ECS cluster. And on those EC2 instances, you will have the Docker runtime or container runtime generally, so that containers can run. And also you're going to have ECS agents installed. And this way, the control plane or ECS processes can communicate with each individual EC2 instance and manage them. So at the end, it means that you have a control plane that helps you manage all your containers and automate some of these complex things that you don't want to do manually and repeatedly. So you have delegated the management of your containers to an AWS service, so you don't have to worry about that. However, you still have to manage the actual virtual machines, the EC2 instances. Meaning you have to create the EC2 instances, you have to join them to the ECS cluster, and when you schedule a new container, you have to make sure that you have enough EC2 instances and resources to schedule the next container. You also have to manage the server operating system, updates, patches, and you also have Docker runtime and the ECS agent, as I mentioned. So all of these are basically part of a virtual machine that you have to still manage. So you're not managing the containers anymore, that's delegated, but you still have the server, right, that you have to take care of. And obviously, if you run out of resources, you have reached your maximum capacity and new container needs to be scheduled, then you need to add and provision a new EC2 instance. On the upside, of course, you have full access to your infrastructure, which is an advantage if you need full configuration, access, and power of the infrastructure that's running your containers. So now you have delegated the management of your containerized application or your containers basically to the AWS service, which of course makes your operations easier. However, you still have the infrastructure to manage the virtual servers. Now, what if you wanted to delegate management of the infrastructure also to AWS? So you want the container lifecycle to be managed by AWS, and you want the hosting infrastructure to also be managed by AWS. Now there is an option for that, and it is called AWS Fargate. So Fargate is basically an alternative to EC2 instances. So instead of creating and provisioning EC2 instances and connecting that to the ECS cluster, you create Fargate instance and connect that to the ECS cluster. So how does Fargate work? Fargate is a serverless way to launch containers. So you take a container that you want to deploy on AWS, that you want to be managed by AWS service, container orchestration tool like ECS, and you tell AWS, here's my container, please run it. And you hand it over to Fargate. Now at this point, you don't have any virtual machine that will run your container. You haven't provisioned anything or any server yet. You just have the control plane of ECS and you have the Fargate interface. So you give your container to Fargate and you say, please schedule this. Fargate will then take your container. It will analyze by looking at your container how much resources your container needs to run. How much CPU, how much RAM, how much storage it needs to be deployed and to run. And then Fargate will itself automatically provision a server resources for that specific container. And then it will deploy and run that container on the provisioned server resources. So this happens automatically. And every time you add or you hand over a new container to be deployed to Fargate, Fargate will do the same. It will go and provision server resources to run that specific container every time you want to schedule a new container. So advantages are obviously you don't need to worry about having enough EC2 instances and resources to schedule a new container because you don't have to provision anything beforehand. It all happens per demand, basically. Every time you want to schedule a container, server resources get allocated and provisioned for it. And because you don't have to provision the infrastructure before you deploy containers, you always have only the amount of infrastructure resources needed to run your containers. And that means you pay only for the resources that your containers are actually consuming. And also, it really easily scales without fixed set of EC2 resources defined beforehand, since every new container gets new resources. The pricing is based on how long the container runs and how much CPU and memory was requested for that container. So for comparison, for EC2, you obviously pay for the whole server, even though you might not be running any containers on it or just a few maybe. And for Fargate, you only pay for the resources that container is consuming. So now you have your infrastructure managed by AWS using the Fargate service, and the containers that are running, that were scheduled through Fargate, are now also managed by ECS. So you have multiple levels of your infrastructure and the application on it being managed by AWS services. So basically, now the only thing that you have to worry about and manage is the actual application itself. So you develop the application, you create containers, and that's it. And then you just deploy the containers on AWS infrastructure, which obviously is a great thing. However, again, if you need more access to the underlying infrastructure, you need access to the actual infrastructure running your containers, then you have the flexibility and access with EC2 instances. And of course, when you run your containerized application on AWS infrastructure using the AWS services, you have advantage of using any other AWS services from the AWS ecosystem, right? So both EC2 and Fargate and ECS and all these services obviously fully integrate with the whole AWS ecosystem, right? So this could be CloudWatch for monitoring, Elastic Load Balancer for load balancing, IAM for permissions and users, VPC for networking, and so on. Now, this is how you can let AWS manage your containerized applications using ECS. Now, what if you want to use Kubernetes? As you know, Kubernetes is the most popular container orchestration tool currently. So a lot of projects and a lot of companies actually use Kubernetes. So can you still use AWS infrastructure if you want to use Kubernetes? And how can you use that? AWS actually has another service which is for managing Kubernetes cluster on AWS infrastructure. So alternative to ECS, you have a service called EKS, which stands for Elastic Kubernetes Service, that lets you manage Kubernetes cluster. So the difference or advantage of using EKS is the first thing that I just mentioned, which is if you're using Kubernetes already and your project wants to deploy their Kubernetes cluster on AWS infrastructure, obviously you want to be able to keep your Kubernetes tool and not use a proprietary container orchestration of AWS. You have an option of doing that using EKS. So that's the first obvious reason. Another reason, if you do not necessarily think about using Kubernetes or you don't already use Kubernetes in your project, making decision between ECS and EKS is basically ECS is specific to AWS, right? So if you decide at some later point to migrate to another platform, you will not be able to move that cluster to another platform because it is really integrated and based on AWS. With EKS, though, because it's managing the Kubernetes cluster, you can easily migrate Kubernetes because it's not specific to AWS, right? It's an independent tool which you can use anywhere. So you can much easily migrate Kubernetes cluster on another platform or maybe even on premise, right? If you have your own infrastructure in your company, then you can use the same configuration, same tools across multiple platforms. So that's a major advantage of using EKS versus ECS. Now I have to mention here that even though Kubernetes is an independent tool, if you're using it on AWS, let's say using EKS, and you use a lot of additional tools and services from the AWS ecosystem in your Kubernetes cluster, then of course when you migrate your Kubernetes cluster, you'll have to replace those services with some other tools because they will not be available on another platform, right? Because these services are, again, specific to AWS. So just know that it's not 100% easily migratable, especially if you're using AWS specific services in your cluster. So that's maybe one thing to consider. Another also important reason for using EKS versus ECS is that if you use Kubernetes, which is again much more popular orchestration tool than ECS, you also have access to all the Kubernetes tools and plugins and things are developing in the Kubernetes ecosystem, like Helm and some other tools that integrate well with Kubernetes. Now, on the side of ECS, a more suitable use case for ECS is if you have less complex containerized applications that maybe don't need this full-fledged Kubernetes cluster to run in. In this case, you can actually deploy it on ECS cluster. And also you don't pay for the ECS control plane compared to EKS cluster control plane. But generally, I think EKS is much better choice for managing and orchestrating your cluster on AWS infrastructure. Now, how does EKS work? It's actually pretty similar to how ECS works. With EKS, you create a cluster which represents the control plane. So when you create an EKS service or EKS cluster, AWS will provision in the background Kubernetes control plane nodes that already have all the Kubernetes control plane services installed on them. So all of that is managed and provisioned for you. You don't have to worry about control plane nodes for your Kubernetes cluster. Also, because these control plane nodes are managed by AWS, it will automatically replicate the control plane nodes across multiple availability zones. So if you're creating EKS in a region that has 3 AZs, then you will get automatic replication of your control plane nodes on all of those AZs. And of course, then you have the storage, which is the etcd part of the control plane processes, which stores the whole cluster configuration, basically the current state of Kubernetes cluster. And that storage needs to be replicated as well and needs to be backed up because you shouldn't or you can't lose the data. Otherwise, you basically lose all your cluster configuration and you won't be able to recover your cluster. And again, because it's a managed service, AWS will also take care of storing the data, replicating the etcd store, and backing it up properly. So basically, control plane nodes are not your worry anymore when you use EKS. So with EKS, you have the control plane nodes configured. Now you need the worker nodes. you need infrastructure that actually runs your pods and workload. Again, same way as in the ECS, you will create EC2 instances, the so-called compute fleet of multiple virtual servers, and then connect them to the EKS. In the example of ECS, we saw that these EC2 instances, this compute fleet, each server had the ECS agent installed. This way, the control plane could communicate with the individual nodes. In this case, we're in the Kubernetes world, so worker nodes will have Kubernetes processes. So this way, control plane can communicate with worker nodes just like they do on any platform, right? It's not specific to AWS in this case. So you have the worker nodes made out of EC2 instances that are connected to the EKS cluster. However, in this case also, you need to manage the EC2 instances yourself. You have to manage the operating system and the processes running on them. In EKS cluster, however, you have a possibility to choose a semi-managed EC2 instances for your cluster. So basically, you can group your worker nodes into node groups, and that node group can actually handle some of the heavy lifting for you and basically make it easier for you to configure new worker nodes for your cluster. For example, worker nodes or EC2 instances managed by node group will get all the processes necessary installed on them. So you don't have to worry about installing container runtime, Kubernetes worker processes, etc. for them to make it into worker nodes. So that means you have an alternative between completely self-managed EC2 instances and semi-managed EC2 instances through node groups. And when working with EKS cluster, it is actually a good practice to use node groups because they make a lot of things simpler, and you can also create multiple node groups to group your worker nodes in different logical groups. But as I said, it is still semi-managed. You still have to take care of some other stuff. For example, autoscaling, right? You don't have the autoscaling configuration out of the box. You still need to configure things in Kubernetes and on the AWS side to make autoscaling possible. So you have to take care of creating new EC2 instances, removing them, etc. However, if that's also something you want to delegate to AWS, if you don't want to worry about that, you can also for EKS cluster use Fargate instead. And in that case, you would have fully managed worker nodes in addition to fully managed control plane. So these are the 3 steps of worker node infrastructure management you have available in AWS. Or you can even use both EC2 and Fargate at the same time for the same EKS cluster. So basically from the hosting perspective of where your containers are running, having EC2 and Fargate as alternatives, this part is pretty much the same whether you use ECS or EKS. And this basically gives you the combination of the services that you have as an option if you want to run a containerized application on AWS using a container orchestration tool to manage them. And in this part, we're actually going to cover usage of EKS service because, as I mentioned, it is using Kubernetes under the hood, and this is in many scenarios the better choice for orchestrating your containers. So we're going to look into EKS and we're going to set up a cluster on AWS using Elastic Kubernetes service. So let's see on a high level how EKS works. The first step is we provision an EKS cluster with control plane nodes, which is completely managed, replicated, and configured by AWS itself. Then we create a group of EC2 instances so that we don't have to create the EC2 instances individually. If you need maybe 5,000 virtual machines, maybe even 1,000 virtual machines, you obviously don't want to create those instances one by one. You want to create a group of them or fleet of them, and you can do that using something called node group. So you can create a node group with a bunch of virtual servers, and then you can connect that node group or multiple such node groups to the EKS cluster. Or you can use Fargate as an alternative. And now you have the control plane nodes and worker node group connected. And that gives you a complete Kubernetes cluster. And once that's done, you can simply connect to the cluster using kubectl command and start deploying containers inside that cluster. Now we just saw two of the services on AWS that are specifically for containers. And there is one more container service on AWS, and that is Amazon ECR, which stands for Elastic Container Registry. So basically this is just a repository for container images. Alternative to Docker Hub or Nexus Docker repository where you can store your Docker images, for example. Advantage of using Elastic Container Registry is, of course, because it's part of the whole AWS ecosystem, it integrates well with other services. So for example, if you use EKS with EC2 instances, for example, then it will be easier to connect it and configure your cluster with ECR to fetch the instances, but also to do some other stuff like automatically get notified when a new version of the image gets pushed to the registry and then automatically download that into your cluster. And also some other additional features. And of course, you have all those abilities because these are all AWS services, so they are tightly integrated with each other. And ECR is pretty easy and straightforward to use. You basically create your private repositories for your different application images or Docker images, and you can start pushing different versions or different tags of that image to those registries. And then, of course, use that endpoint to download the images from the cluster. So to summarize, on AWS, we have three main container services. The first one is for storing container images in private container repository, which is our ECR. And the other two are for orchestrating and managing our complex containerized applications on AWS infrastructure. And these are ECS and EKS. There is one more container service on AWS, which is basically a fully managed Red Hat OpenShift service. But this is more a specialized tool, and we're not going to see that in this module, but they have recently added that to the container services list as well. And in this part, we're going to look at ECR and EKS services and use them in our CI/CD pipeline to build and push images to ECR and deploy them to Elastic Kubernetes Service.